Welcome back to the Fundamental Theorem of Calculus, Part 2. Okay, so here with my integral, now instead of going from a to x, I'm going to a to b. So we have two values, 1 to 2, 3 to 7. So 1 to 2, 2 to 5, whatever they are. What's going to happen is we take the antiderivative and evaluate at our limits here. So if you remember, f of x, when we were doing the antiderivatives, we called it a capital F of x. So what I'm going to do is I'm going to take the antiderivative of f, which is capital F. I'm going to plug in b, and I'm going to do the same. I'm going to plug in a, and I'm going to subtract those two. And that's how we evaluate our definite integral. So when we have an upper bound and a lower bound, this is called a definite integral. And it's going to give us a value from 2 to 5. In most cases, this is going to give us the area under the curve if our function is always positive. So if you check back for our next video, I'm going to explain the differences when we have positive and negative area, what's happening there. Okay. So we're just going to go through and solve these, and like I said, I'm going to verify how part 1 works. So I'm going to take the antiderivative of x squared, which is x cubed over 3, and I'm going to evaluate from 2 to 5. So I'm going to plug the 5 in, 5 cubed over 3, minus, I'm going to plug the 2 in, 2 cubed over 3. So this is 125 thirds minus 8 thirds, which is 117 thirds. Here's my solution. So that is the exact area under this curve. Again, I'll describe what that means exact in our next video. Okay, same here. So antiderivative of 1 over x is the natural log of the absolute value of x, and we're going to evaluate from 1 to 2. So the natural log of 2 minus the natural log of 1. The natural log of 1 is 0, so this just is the natural log of 2. Okay, see if you can try this next one on your own. Push pause, come back, test it out, see how you do. Antiderivative of cosine is sine of x, and we're going to evaluate that from 0 to pi over 6. So I'm going to plug in my pi over 6, and I'm going to subtract my sine of 0. The sine of pi over 6 is 1/2. Sine of 0 is 0, so this solution is 1/2. Okay, so on this last example, I'm going to verify that part 1 works by splitting this up into 2 parts. I'm going to start by evaluating my function here. And then I'm going to go back and take the derivative. So the antiderivative of cosine is sine, and I'm going to evaluate it from 2 to x squared. So I'm going to plug in my x squared, and I'm going to plug in my 2. Since the sine of 2 is not a pretty number, I'm just going to leave it as is, and now I'm going to come in and take the derivative. Well, the derivative of sine is cosine, and now I have to take the derivative of my x squared, which is 2x, minus the derivative of sine of 2, that's just a number, so that derivative is 0. So I'm left with 2x times the cosine of x squared. But if you remember, part 1 from the fundamental theorem, all I had to do was replace and multiply by the derivative. So that would give me the cosine of x squared times the derivative of x squared, which is 2x. Same solution, not as much work. Okay? Hopefully that helps. Go forth and solve your integrals. Let me know if you got any questions.